Okay, so we're finding the area under a curve using sigma notation. So this right here tells us to add. N is the number that we're ending with, and then I is what we're starting with. So the change in x, so right here is change in x, which you can see throughout the sigma notation, is b minus a over n, and then this is going to be on the a to b interval, as you can see in the graph. Okay, so this is how to use the rectangle method to find the area under a curve. So we're going to be using the midpoint in this case, so on the interval 1 to 5, so the middle between 1 and 2 is going to be go up to where that point meets, and then you draw to the left and the right of that to follow that to make the rectangle that you make right there. And then you find the midpoint between the next interval, so that's going to be right in between 2 and 3. You follow the line up to right where the line is, where you meet the point, and then you draw your rectangle. And do this again until you make it through 4 subintervals, which is why you should have 4 rectangles drawn after you've gone through each one. Now the midpoint is probably one of the more complicated ones out of these, but if you just draw the line slowly and make sure you connect your dot up to that line, you should be good. Okay, and then write endpoints on the interval. So this means that you're going to take the endpoint that is from the right. So you're only using 4 subintervals and you have 5 numbers on your interval. So you're going to take the one that is to the right on a number line. So you start off with your 2 right here. So you go up, follow till you hit the line. That's your point, and then you go over to the left and draw down. And that's your rectangle. So then you start at the next number, which is 3. So you go up and then over, and you're drawing your rectangle again. Again, you repeat this process. So you go to 4, over, and then you go to 5, draw your point, then you head over. Okay, next is your left endpoints. Your left endpoints, you go from your left point, which is 1 in this case. So you go up from 1, hit the point on the graph, draw over to the next part, and down. Then you go up again, and you go hit your point, and then you draw over till you meet your next part of the interval, subinterval, and then you hit there. Repeat this until you have 4 rectangles because you need 4 subintervals. Okay, and there, that is how you draw the rectangles that we are using to calculate this area. Okay, so now example 1. Find the area under the graph of f of x e to the x on intervals x equals -2 and x equals 1. Estimate taking sample points to the left endpoints using 3 subintervals. So x equals -2 and x equals 1 are going to be, is our interval, and then 3 is our subinterval, and we're using left endpoints. So 3 is our n in this case, and so then we're going to also look at the change of x, which is the formula b minus a over n. Well, we know our n is 3, and then using our points that we have up there, which is -2 and 1, which, there we go. And so that means -2 is going to be our a, and 1 is going to be our b in this scenario. So we plug those in to find the change of x. So we're going to do 1 minus -2 over 3. And that's change of x. So then when you solve that, you're going to get change of x is equal to 1. Okay, so now we write out our formula, which we learned earlier on. So this is our sigma notation. So L3 means, because we're using 3 subintervals from the left, so you write down your 3 sigma, and then I equal 1, f of x I, and the change times the change of x. So now we're going to do this in terms of the graph and the equation. So L of 3 is equal to f of, so we're starting from the left, which means we're going to do f of -2 from this interval. That's the one furthest to the left. Then you add the next interval over, which is going to be -1, and the next interval is f of 0. Now you're only using 3 subintervals, so there's only needs to be 3 in there. And then you're going to multiply all this by the change of x, which we have found above is going to be 1. So we don't really need to rewrite that since it's just 1. We know what that's going to end up being. So now, so L equals 3 is going to be, so you find out what each one of these points is. So plug in -2 into the equation e to the x, and then you write that down. So that's what we do for each one of these, which is what you're seeing me do right there. We add those together and multiply everything by your change of x, which in this case is just 1. And this is all from 3 left intervals. So now, let's see this a little bit more from the graph point of view. So this is how you would draw your rectangles in this scenario. So our interval is -2 to 1. So you're going to go from the left over. So you go up from the left point, find your point on the graph, go over to the next interval, and then go down. Then you go up from there, hit your point, and go over, and then go back down. So that's your rectangles that we're really finding the area of. So that's really a picture way of looking at the area that we're finding right now. So there's 3 rectangles because it's a interval of 3. So then when you add those all together and multiply it out, you get 4.221. All right, so now example 2. Find the area under a curve of f of x equals sine x graph. The interval is 0 and pi, which is our a and b, using 2 subintervals, and we're using midpoints in this one. So 2, we already know is going to be our n because it's a subinterval, and we're using midpoints. So we write down an m and 2 because our subinterval is 2. Now we write our sigma notation, which means it's going to be I equal 1, and then our n is 2 in this case, so you put 2 on the top. And then you're going to do the f of xi times the change of x. Okay, so now we have to find out what our change of x is going to be in this scenario. So our change of x, remember, is b minus a over n. So our b is pi minus a is 0 over n is 2. So when you solve this out, you're going to get pi over 2. The next part that we do is that we plug in and we find out what our f of x intervals are going to be on this, but we need our midpoints. So we have to go between the intervals that we are given. So we go in between 0 and pi over 2, which is pi over 4, in between pi over 2 and pi to find 3 pi over 4. Okay, so those are our points we're going to be using. So we write m2 is equal to pi over 2, because that's our change of x, times f of pi over 4 plus f of 3 pi over 4, because those are our midpoints we're going to be using. We're not using 0, pi over 2, or pi. We're using the midpoints. Okay, so then we go from this, and we need to draw out what we're doing right now. So that's your midpoint. You go up from there, and then you go over from one side and the other, so that way that point you made is the middle of your rectangle. And then we do that again. And in this scenario, in the sine graph, you can see that these are actually 2 equal rectangles, which we're going to figure out as we solve this problem. So then you find what your function is equal to. So in this case, it's square root of 2 over 2 plus square root of 2 over 2, and then you multiply it out and you get pi square root of 2 over 2. All right, so now we're on example 3. And we have 1 plus x squared. So we find the area of the curve on the interval -1 and 2 using right endpoints with 6 subintervals. So we have our a and b, we have 6 subintervals, which 6 is our n. So now we're going to draw out our points because we're using right endpoints and we're only going from -1 to 2. So in this scenario, we have 4 points on the basic line, but we need 6 in this scenario. So we're going to go in between each of those and figure out what that's going to be. So here it's -1/2, then we have 1/2, and then we have 3/2. So those are going to be our subintervals in this equation. So now that we have those little points figured out, we can also look and see, so we're going from the right, so it's our 6 intervals. And then you write sigma notation, so we're going to do the I equals 1. And then, oh, it's got a little blurry, sorry about that. And so there's 6 over the top. And then f of xi times the change of x. Okay, so our change of x, remember, is going to be our b minus a over n. So our b is going to be 2 minus a, which is negative 1, and over 6. So that's going to get us to be 3 over 2. Oh, sorry. 3 over 6, which is 1/2. Okay, then we're going to make our graph, because in this scenario it did not give us our graph. So we need to figure out what the graph of 1 plus x squared is going to look like, so that we can draw our rectangles. So we make the little graph, we find our points, so it's going to be starting at 1, and then you write your x squared graph, how you usually would. Okay, so then we're going from the right. So the right is going to be at 0 initially. So, sorry, that was not if we were using 4 intervals. This is 6 intervals. So we need the middle of these. So that means we're going to start from the 1/2, go up, hit the right point, go over, hit the right point, go over. So that's what we're doing, drawing each of these little ones. And as you can see, when you use more sub-intervals, it's actually more accurate and closer to the line. So this means this area is going to be a little more accurate than these other ones we've done. So now R6 equals change of x, which is 1/2, plus f of negative 1/2, plus f of 0 plus f of 1/2 plus f of 1 plus f of 3/2 plus f of 2. So these are a lot of our subintervals because we need 6 in this problem. Now, as you can see, there's actually 7 different intervals up on that line up there, but we only need 6 of them because we're doing it from the right. Now, r equals 6 equals this, and then we need to find what each of these are on a graph. So we plug all these into our function, and we find out what they all are. So I've calculated those all out, so we know what each one is. I'm writing them out. And then you add all these together and you multiply it by your change of x. Don't forget to multiply by your change of x each time to find this area. So once we add them all together, you get that 13.75 times 1/2 is going to be equal 6.875. And that is your answer for the area. I hope this all helped you. Thank you. Bye-bye.